All right, Marvel, so we are here to start our learning regarding adding and subtracting fractions. We're going to kind of extend what we did in 4th grade, extend what we did at the beginning of the year, and then continue moving in that direction. All right, so we're going to go ahead and start with a review from something that we did earlier in the year. We're going to look at adding fractions with unlike units. Of course, make sure that you're pausing and rewinding as you need, so that way you can have appropriate understanding. And please remember to have something to write on and write with, because you should be pausing the video to work out the problems with me as we go. All right, let's jump right in. So we know that if we have 3 apples plus 4 apples, we're going to say that it's 7 apples. But if I have 5 oranges plus 2 apples, I can't do that. I'm going to have to rename it as 7 fruit, right? Because we need to have similar units. In this first one, I'm adding apples and apples, so that's cool. I can go ahead and put that at 7 apples. But in this one with its oranges and apples, I can't say it's 7 oranges because it's not. I can't say it's 7 apples because it's not. But I can say that it's 7 fruit because I'm renaming it as that similar unit. So that's what we're going to be doing today with our fractions. Because of course fractions are nothing to be scared about. It's just a different unit. All right, so we're going to use area models to help us. All right, so if I have 1/2 plus 1/4, I'm going to go ahead and show this with an area model. Okay, so there's 1 and there's 2. Okay, so I'm going to have 1/2. And then I'm going to have 1/4. And you remember we can go ahead and show them one with vertical lines, one with horizontal. All right, I have 1/2 and 1/4. Now, I need to go ahead and make sure that they have a similar unit, that they have a similar denominator to ensure that I'm able to actually combine them, because right now they're different units, right? If I have 25 plus 36, I'm not going to add by 3 in my 5 because they're different units. Okay, how am I going to get a similar unit? Well, I can go ahead and mirror it. So I'm thinking about using my multiples. What is a multiple of 2 and 4 that they both go? Well, it's actually 4, right? I can go ahead and mirror my fourths on here. 1, 2, 3. Okay, so there's my fourths, and I can see that 1/2 is the same as 4/8, right? And then I can mirror my half on here, and I see that 1/4 is the same as 2/8, right? So all I'm doing is I'm just renaming them, and then I get my total of 6/8. 1/2 plus 1/4 is the same as 6/8. Let's look at another one, and then I'm going to give you one to do by yourself. All right, so let's look at this one. 2/3 plus 1/4. Okay, let's go ahead and start by showing our area models. Why don't you go ahead and pause the video right now, and I want you to show 2/3 on an area model and 1/4 on the area model. Go ahead and pause and do that now. All right, so we should have gone ahead and shown our 2/3 and our 1/4. Now I want to go ahead and rename it as a similar unit. Now, when I'm thinking about this, I'm changing 2/3, or I'm renaming versus, and I'm renaming 1/4. How am I going to do that? Well, I have to think about which multiples. So I can go 3, 6, 9, 12. I can go 4, 8, 12. Oh, wow. Okay, 12 is the same. Let's show how we get that. How are we going to change both of these into 12? How can we rename them into 12? Well, we're going to mirror it, right? Here's my fourths. I want to go ahead and show my fourths here. I've split each of my thirds into 4 parts. I'm multiplying by that fraction of 4/4, which is the same as a whole. I know when I multiply by 1, I'm not changing the value, I'm just changing the representation. And I get that 2/3 is the same as 8/12. I have 1, 2, 3, 4, 5, 6, 7, 8/12 that are still colored in. Let's do the same thing for the fourth. I'm going to go ahead and show my thirds. I'm showing my thirds in each of my pieces, which means that I see that 1/4 is the same as 3/12. I'm going to go ahead and add 8/12 plus 3/12. That's going to get me 11/12. All right, I want you to go ahead and try to solve this one by yourself. So go ahead and pause and work this out, and then we'll debrief it once you hit play again. Go ahead and solve 2/5 plus 2/3 using our area model. Again, go ahead, pause, and solve. All right, so let's go ahead and rename these. That way we have a similar unit. I have my fifths, I have my thirds. I'm going to go ahead and reflect that on each of them. All right, so I'm splitting each of my fifths into 3 parts, including those 2 that were already colored in. Now I'm multiplying by 3/3, same as 1 whole, so my identity property tells me that My value is not changing, just my representation. So I see that 2/5 is the same as 6/15. You could also just count 1, 2, 3, 4, 5, 6. There we go. Now I have 2/3. I'm going to go ahead and show my fifths on there, and we get what? We get that 2/3 is the same as 10/15. All right, let's go ahead and add them together. So we have 6/15 plus 10/15, and we would have got 16/15. Now here's where it gets fun. What is this called? What is this called? That is called an improper fraction. That is correct. It is called an improper fraction because my numerator is greater than my denominator. So what can I do? I can go ahead and break that down into 1 and 1/15. All right, let's go ahead and take it one step further. And now let's think about if we continue to have those values over 1, okay? So let's look at this one again. I'm going to go ahead and model this one through. So I'm going to have 1/2 and 3/4, 1/4, 2/4, 3/4, and 1/2. Let's go ahead and rename them. So I'm just going to actually change my halves into fourths this time because I noticed that I can go ahead and do that easily. All right, so now I have 2/4 plus 3/4, and I'm going to get, oh, that's a messy 4. I'm going to get 5/4. Again, what are we going to do? It's an improper fraction. So I'm going to pull out that whole. I know that 4/4 is the same as a whole. So when I pull out that whole, I have 1/4 left over. All right, let's go ahead and have you guys try. Once you try these two last ones, making sure that you fix or that you rename any improper fractions as mixed numbers. Go ahead and pause and work these out, and then come on back when you're ready for us to go over it. Okay, so looking at this first one, I'm going to go ahead and rename 4/5 as 8/10. I'm renaming 1/2 as 5/10 to find that common denominator, which means that I'm now doing 8/10 plus 5/10. 8 plus 5 gives me 13, and my unit is tenths. So now I have 13/10. All right, what am I going to do? Improper fraction, more on the top. So let's go ahead and pull out that whole. I know that whole is 10/10. If I pull out 10/10, that means that I have how many tenths left over? Well, 10 plus 3 gives me 13. So I know that 13/10 is the same as 1 and 3/10. Go ahead and make sure that you've solved this next one, and then we'll go over this one. All right, so I've gone ahead and renamed. My common denominator is 15 because that's a multiple of both 3 and 5. 3, 6, 9, 12, 15. 5, 10, 15. All right, so when I rename 2/3, I see that that is equivalent to 10/15. I'm just changing my representation, not my value. I'm then adding that to my 3/5, which I've renamed as 9/15 because it is the same value. All right, 10 plus 9 gives me 19. My unit is 15. Let's go ahead and pull out that whole. A whole is going to be 15/15. What plus 15 gives me that 19? 4. So it's 1 and 4/15. All right, friends, again, please make sure that you pause, reround as you need to make sure that you have appropriate understanding and that you've been able to work out these problems. Go ahead and progress to your problem set. Remember, you're going to record yourself showing me your problem set, and then you are going to complete the exit ticket. You have to get a score of 2 on the exit ticket in order to be able to move on. Let's get that mastery.